Hello everyone! Ohayo gozaimasu! Namaste! Joke lang, maayong buntag kaninyong tanan. So, good day everyone. Welcome again to my YouTube channel. So, where we learn things like, especially in mathematics. So, happy to see you again. We are back again to our next topic for, not really a next topic, perhaps this is another topic not related to the week one that we just discussed last time. So before anything else, let's just share life first. How's life? How's life so far? So I hope you are doing all great, awesome, and of course you are still productive in spite of the increasing cases of our, active cases for this what we call pandemic. So I hope that everybody or all of you are doing good. You are still fine. And of course, let's just pray to God that God will provide us or will protect us against this virus. Okay, soon will be. Let's just be positive, everybody. That soon will be everything will be back to normal. We will see each other like face to face. Especially, I'm talking about the students and teachers where you have your online classes. Then probably soon it will be go back to like face to face interaction. So now, again, to those who don't know me yet, I am Mr. Alistair Apale. You can call me Emma Watson. I just changed the name of my name so that it will be easier for you to research or to search it in YouTube. Okay, so now, how's my kabayan? I hope everybody is so excited for the new things that you will learn this session. So in this session, we will just be happy, smile in spite of the new things that we learn that we will learn in mathematics. Because when you try to hate mathematics, don't you know that it will become, or the subject will also hate you? That's why you found it sometimes difficult to really understand the concepts in mathematics. Actually, that's really my secret. Why the subject tried to love me, and I also love the subject because it's just like a piece of cake. What I mean is, it's like in your mind. So you can just change your mind, and after that, everything will go well. Okay. Who among you here wants to be good in mathematics? So everybody wants it. So now, are you ready? So if you are now ready, then our topic will be something like it's in grade 7. This is a part of the second or third quarter, but for grade 8, this is like an introduction before they will talk about special products and factoring. For grade 9, yes, this is also involved, or this will also be discussed during the square root properties like rational exponents. Yes. So now, let's just be happy and let's just enjoy the learnings. Don't be pressured. Again, we are in the midst of pandemic. No negativity, and always be positive so that you will have a positive outlook and a happy life in the middle of pandemic. Okay, just like Emma Watson she's always happy and positive in life. That's why life is so wonderful and colorful. Okay, so much for that. Let's now proceed to our main topic this afternoon. Not afternoon, this session. So I'll be sharing now my prepared PowerPoint. I hope everybody will appreciate it. This is just simple compared to the first one that I made. So now, okay. So our first quarter, of course, this is intended for the advanced algebra, especially those who have advanced algebra subjects. So I am inviting everybody, those who are listening, those who are watching this video, I want you to just click the like button and also the comment button. And of course, the most important thing, the subscribe button, or yeah, the subscribe. If you see subscribe, then click subscribe so that you can subscribe to my channel. It's a great help. As if I'm starving already. Okay, so you can just you can just share it. the best thing to do is subscribe and share it to your friends so that at least you can help grade 7 students, you can help grade 8, grade 9, especially those who have difficulty in the topics that we are discussing in this channel. So you can just share it and subscribe to your friends, classmates, or even to your parents if they want to learn more. Okay, so now, so our topic will be something related to this. Oh, you can see words, whole numbers, exponents. So I highlight the word exponents. So, yes, our topic is something related to exponents, as you can see, and on the screen. Of course, it's so obvious. So now, our topic will be related to integral exponents. So, do you have any idea, or have you encountered the word integral exponents? Sir, it sounds difficult. It sounds weird. The word integral. So don't be bothered about the word integral. It's just a word. It will not bite you. It will not even scare you at all. It will never kill you. It will love you. Okay, as long as you will listen to our discussion this in this session. Okay, so of course we have to be guided with our learning competency or objective. So of course our learning objectives for this lesson or video is to determine the laws of exponents. So if there is law, or if there are laws rather in our country or in the world, there are also laws in mathematics, especially in exponents. So we will be talking about, or you're going to determine in this lesson about the laws of exponents. So another thing also, you are going to illustrate that positive integral exponents to zero and negative integral exponents. So that's part of our main objectives or learning competency this competencies rather in this video discussion. So are you ready? I hope you're all ready because I'm ready and very excited to really show and to share my expertise and my knowledge about this topic. Okay, of course, I want you to really be guided with the guide questions aside from the objectives that I just mentioned a while ago. I want you to be guided with the questions, with these questions. The first question, I want you to learn the answer about this or find the answer after that or during the discussion of this video. So, what is an exponent? What is an exponent? The second one is, what is a base? What is a base? Okay, so the third one is, how do you define integral exponents? Again, how do you define integral exponents? So that's the next or the third question that I want you to learn this video discussion. Third is, what are the laws of exponents? So what are the laws of exponents? And lastly, I want you to answer or be guided with a question, how to calculate exponents. So how to calculate exponents. So these guide questions that I am presenting to you now on the screen are very important to answer during and after the discussion, because these are the lessons that I want you to grasp. You know what's grasp? As in you can just feel it and learn it and will never forget it. Okay? So now, to start, of course, we really have to know the basic terminology in this lesson. So I will be going right away to the basic terminology. So are you familiar with the a to the power of m? Again, you can read it. Those who are beginners in algebra, you can read that one or this one, this term, sorry, for a while. This one, you can read this one as a to the power of m. What's in a to the power of m? What's the term? So a to the power of m is an expression. It is a term. Okay, one term which is related to exponents or exponential notation. Do not be confused when you hear the word notation, because the word notation is just it's just another thing to represent something in mathematics. So we use symbol as notation. So when we say a to the power of m, what does it mean? Let's try to define them. A to the power of m there is the exponent, okay? Exponent. So m is the exponent and a is the base. Again, a to the power of m, it's very important in our topic this afternoon. Not afternoon, I keep on saying afternoon session rather. So a to the power of m is a term or related to exponent or integral exponents where m is the exponent and a is the base. M for exponent and a for the base. Okay, a for the base. Yeah. So let's continue. So what is exponent? As you can see in the on the screen, when we say exponent, class, in exponential notation, again, do not be scared about the word exponential notation because it's just a term used to represent exponents or the form of exponents or the language of exponents. Okay, so exponent, again, in exponential notation, it is the number of times the base is used as factor. Again, the number, oh, there's an advertisement. Okay, because our house is just near the street, so it's very noisy. Okay, so much for that. Okay, when we say exponent in exponential notation, as what I said, it is the number of times the base is used as a factor. So in this case, in the example A, this one, the A, how many times the base, this one, letter A, in this expression or term, how, or the number, or it tells us, when we say exponent, it tells us the number of how many number, or what I mean is the number of times this base A is used as a factor. So that's what we call it. Sorry, that is what we call exponent. So what I mean is the exponent in exponential notation tells us the number of times that the base is used as a factor. So if m is equal to 3, in this case, if a is to the power of 3, rather, what I mean is if m is equal to 3, where exponent is 3, in this expression, that means how many times that this base a used as a factor. So the exponent tells us about the number of times that the base is used as a factor. So in this case, a is used as a factor 3 times since the exponent is 3. Got it? I know you got it. Okay, another thing also is the base. What is the base? How do you define the base? So sorry, I cannot really use the full of my full voice that I have because it's early evening already. So I have to respect the neighborhoods. They might, they might, I might disturb them. They're already sleeping. So, but me still recording, but still fine. It's my passion to really help everybody to learn something in my subject or in this subject or in this topic. Okay. So again, the base in exponential notation, it is the number or variable. Again, I highlight, it's not always a variable. It's not always a number. It could be a number or a variable. So do not forget this. So in exponential notation, base refers to the number or variable that undergoes repeated multiplication. So this is the one being multiplied or being used as a factor that is a base. So again, I want you to remember the definition. When we say exponent, it tells us the number of times that the base is used as a factor. And when we say base, it is a number or a variable that undergoes repeated multiplication. This is what we are multiplied, okay, in here. That is the base. Okay, so another thing also, I'm so sorry. Okay, another thing. So this we can illustrate in this form. For a while I've just cleaned the mess here. Okay, so this is how we this is how we illustrate the definition or concept of an exponent and a base. So in this one, 5 in here is the exponent. It tells us how many times the 2 that the base is 2 being multiplied by itself. So it appears 5 times. This is what we call long notation. This one is called 2 to the power of 5 is an exponential notation. Take down note. 2 to the power of 5 is an exponential notation. And this one, the 2, 2, 2, 2, means the long notation. So it shows, the long notation shows how many, what I mean is the exponential notation shows how many times that the base 2 is being multiplied by itself. So it appears 5 times. And that is the meaning of the word exponent and base. So it's very important for you to know and to identify the meaning of it, because that is very useful when you go to a higher form of algebra. Okay, a higher level rather in algebra. Okay, so let's discuss it further. So again, as what I said, exponent, it tells us the value that specifies how many times that the base will be multiplied by itself. So do not forget. That's why I keep on repeating on this so that you will not forget the meaning. So again, exponent class. Exponent is the value that specifies how many times that the base is being multiplied by itself. And also the base in here is the number or variable. So see how consistent is the definition. It is the number or a variable that is being multiplied repeatedly in the expanded form. So these are the difference between exponent and base. So they are really different from each other, but they are in a one term. So I want you to remember that one, okay? So if you got it, just raise your hand and then you can dance. Just joking. Okay. Now, it's very important to know the types of exponents. I know some of you just heard it now. Others already knew about it. So there are types of exponents. We have first the positive exponent. So let's see the positive exponent. So this is a positive exponent where, look at, where the exponent is positive. So in that case, um, 5 cubed is being represented in a long notation as 5 times 5 times 5. So see the exponent and the base, 5. Base is 5 being multiplied by itself, and 3 is the number of times which is the exponent. Okay, another types of exponent is what we call negative exponent. So when we say negative exponent, everyone, that has a negative exponent. Okay, its exponent is negative. Simple, say. So when you have a negative exponent, you can just get its reciprocal to make the exponent of your expression or term positive. Just like this, 2 to the power of negative 4. So get its reciprocal. That's why it becomes 1 over 2 to the power of 4. Another types of exponent is what we call rational exponent. So when we say rational exponent, that means the exponent is in fractions. So a to the power of 1 over n. So you can just write the denominator n as its index and a as its base as radical, and there is 1 over there. So we will not elaborate this one. I'm just showing to you the different types of exponents because we have a separate discussion about this one in the next video. So next is the zero exponent. Of course, from the word itself, zero exponent, there is, or its exponent is 0. So always remember, if the exponent is 0, the answer will always be 1 in all terms. Okay? So again, I will elaborate these negative, zero, and rational exponents in our next videos or upcoming videos. So I want you to subscribe. And if you want to know it, just subscribe, watch, and share. Okay? Put some comments. If you have some requests, then you can just give a request. Okay, we will be focusing on the positive exponent and integral exponents. Okay? So I hope everybody is in the same page. Okay. Why do we use positive integral exponents? Or what do you mean by integral exponents? Anybody? You're wondering why is it that the title is integral exponents? This one. Never mind with the positive because you know what's positive is. Why do we call it integral exponents? Anybody? Okay. From the word itself, integral, what does it mean? Integral means it is taken from the root word, or yeah, from the root word integer. Okay, from the word integer. We borrow the word integral from the word integer. So when we say integral exponents class, I want you to take down notes of this because you cannot find it in the note in the book or any other book. When we say integral exponent, we use the word integral because that means integer. So in short, integral exponents means its exponents rather are integers. So the exponents are integers. That's why we call it integral exponents. So when you hear the word integral exponents, that means that the expression or terms have an exponent which is integer. Okay? So let's formally define it. For any positive integer, or see the word integer, for any positive integer, n in short, n is a positive integer. That's why we call it integral or positive integral exponents. So this can be written as a times a times a, so on and so forth until a to the power of n must be. Okay? Where a is the base, okay, you know it, that a is base. We identified a while ago. N is the exponent or power. Again, n can be also called as power, and a to the power of n is an exponential expression. Okay, it's an exponential expression. Sometimes we call it exponential notation, so don't be confused with the two. But for me, the correct term is exponential expression. Okay, so let's do the next. Okay, now let's go over with our main topic, main menu. So of course, in every dish, there's always a main menu. This is our main dish, rather main menu, main dish. I stand corrected. So laws of exponents. So there are laws of exponents. If you have rules in your in your school, if we have laws in our community, we also have laws in mathematics, especially in the laws of exponents. So let's say, sorry, any number raised to the first power. So before we go over with the laws of exponents, I want you to be to take down note of this basic principle under the laws of exponents. Any number raised to the first power, when I say raised to the power of raised to the first power rather, what do you mean by this? Any number uh, raised to the first power, that means that the exponent is 1. Like this, 3 to the power of 1, 87 to the power of 1, this one. Okay, what will happen? The basic rule in exponents. Okay, so the rule in here is any number, again, any number raised to the first power is itself. Okay, so if any number is raised to the first power, again, first power means the exponent is 1. So the result will be itself. So in this case, going back to the examples in here, this becomes 3. Okay, itself. So 3 to the power of 1 is 3. 87 to the power of 1 is 87. Same with this. This is what is its answer. It's too long. It is time consuming. Okay, so any number or any term that is raised to the first power, the answer will be itself, or yeah, the number itself or the term itself. Just like this, a to the power of 1 is equal to a. So that's the rule for having a first power in your base, in your exponent rather. Okay. So now let's go to the main rules that we have. Actually, I'll be introducing 4 rules, the 4 basic rules under the laws of exponents. The first one is the product rule. What is a product rule? A product rule can be described in this term, or in this case, a to the power of m times a to the power of n is equal to a to the power of m plus n. So it saying goes base, base, add. So in short, when you multiply expression having the same base, what will you do under the product rule? Just take the base, as you can see, you multiply expressions having the same base, a and a. What will you do? Copy the a or the base and add the exponent. See, that's the product rule. That is a product rule. I want you to remember that one. Very important concept under the laws of exponents. So in short, if the bases are the same as I have said a while ago, you can take the base, copy the base A, and then you can add the powers or exponents. Got it? So simple. I know you can do it. So what are the base or bases and the power or powers? Let's see. Let's have an example. 2 to the power of 4 times 2 to the power of 5. This one. How will you solve it? Try to think. Okay, let's proceed. So in the example that I gave, that's 2 to the power of 4 times 2 to the power of 5. How will we apply the product rule in here? So as you can observe in here, class, there are, or the base here, the bases here are the same. So what will we do? When we multiply them, you don't multiply 2 times 2. What did I say? You copy the base, 2, then add the exponents. So 4 plus 5, so the answer is 2 to the power of 9. But if you want, or if you are asked to write the simplest form, then it could be, or yeah, I can accept the final answer as 512. Okay? So be careful with this. When the base is a numerical, a number rather, yes, a number, then you can still simplify it or write it in its simplest form. Okay? So you have options. But for me, it's fine. It's fine if you're going to answer the 2 to the power of 9. But there are cases that you need to simplify it or really solve it. Okay? So, so easy, right? That's what we call the product rule. What's in the product rule? Multiplying, same base. What will we do? Just copy the base and add the exponents. Exactly. Oh, the power of a power rule. Another one is a power of a power rule. Never mind with the 64. The 64 is so excited. Okay, so power of a power rule. What does it mean? What's the rule? Okay, when a base or when a term, as you can see, the term A, when a term is raised to the power of m or another exponent is raised to, yeah, when a term is raised to another exponent, like raised to the power of n, what will you do? That's why we call it power of a power rule. The power is being raised to another power. So that's why we call it power of a power rule. So what will we do? We will copy the base a and then multiply their exponent. So just multiply m times n. So again, power of a power rule states that when an expression is raised to another an exponent, then what will we do? We can apply the power of a power rule. Just copy the base and then multiply the exponent. Simple as that. Okay? So remember the rule. Let's have an example. Example, in this case, 2 cubed raised to the power or squared. 2 cubed squared. So 2 cubed is raised again. We all know that 2 cubed or that this term has an exponent already, which is 3. And then it is raised to another exponent. That's why I told you, you have to really apply, or you can apply power of a power rule when an expression is raised to another power. So, sorry. So what will happen? That gives you what? 2 to the power of 6. Why 6? 3 times 2. So 2 to the power of 6 means 2 times 2 times 2 times 2 times 2 times 2. In short, 6 times. It's not 2 times 6, okay? Not 2 times 6. 2 times 6. This is a big wrong. Okay? I want you to remember this is the correct one. 2 to the power of 6 means 2 times 2, 6 times. Then it gives you equals 64. Okay? So I hope you can follow. Take down notes with the reminders. So another power of a product rule. Actually, I just inserted this one, but this is not really part of the basic laws of exponents. There are only 3. But since I introduced, I put it in the PowerPoint, so I'll just introduce this one. So power of a power, or power of a product rule rather, it is stated in this way or in this form. AB is raised to the power of m. That what will you do? You distribute the exponent to each variable. Yes, variables in your term. So we all know that A has 1 and B has an exponent of 1 or first power. So m times 1, that's why A to the power of m, then copy B, then multiply m times 1. That's why we also have B to the power of m. So you just distribute m to the exponents of each variables that we have in a single term. That's how we apply a power of a product rule. So I want you to remember this notation or law. So it is another saying of distribute the power to the bases, as what I've said. You just distribute m to each bases, A and B. So what are the bases and the power or powers? Let's have an example. 3x quantity, you can read it as quantity 3x, close quantity raised to the power of 4. So let's do the example. Quantity 3x raised to the power of 4, close quantity raised to the power of 4. So how will we solve it? Oh, see, how many bases does this problem have? How many bases? We have 2, 3 and x, correct? So we have 3 and x. So we distribute 4 to your 3 to the basis of your term. We have 3 and x. So what's next? We apply the rule. So we have it 3 to the power. That's why we have 3 to the power of 4 and x to the power of 4. This one. So now 3 to the power of 4 means 3 times 3 times 3 times 3, 4 times, multiplied 3 by itself. So we have 81, not 3 times 4, okay? Be careful with that. That is a mortal sin in math or in here. So x to the power of 4 is x to the power of 4. That's why our answer is 81. This one, we can still multiply it or combine them. So 81x to the power of 4. So this is our answer. 81x to the power of 4. This one our final answer. So I can now, okay, do not forget with the notation. That's how we apply the product of a power rule or power of a product rule. Okay, another rule or last rule or yeah, laws of exponents that we're going to talk about this in this video is the quotient power property or power rule. So what is quotient power rule? From the word itself, quotient, so divide. So in short class, when you divide expressions or terms having the same base. So again, when you divide expressions or terms having the same base, and A, correct? Look at their bases, A and A, same base. What will you do? Just copy the base and subtract their exponents. So M minus N. Actually, I have, a very basic and very easy way to do the or apply the quotient property rule, power rule rather. So let's continue. Saying goes, when dividing an expressions with a power, subtract the powers. They must have the same base. Again, you cannot apply this one if they don't have the same base. It must have the same base, okay? In order to subtract. So what are the bases and the powers or power? Okay, let's have an example. X to the power of 8 over x to the power of 3 or x cubed. So we are going to do it. So sorry, I'm going to clean the mess first, okay? Let's have an example applying the quotient rule. So example, we have x to the power of 8 over x cubed is equal to, again, what will we do? Check the base, their bases, the same, check. So just copy the base and subtract the exponent. So 8x to the power of 8 over x cubed. That's why we have it x to the power of 8 minus 3. Then you have it x to the power of 5. 8 minus 3 is equal to 5. So this is our final answer in this problem by applying the quotient rule. So I want you to observe this one. What if we have this? X cubed, then x to the power of 8. Will you still use the same rule Actually, you can still use the quotient rule, but this is what I want to emphasize in this rule, under quotient rule. Listen, everybody, is very important. My technique in here, especially to my quizzers before, so that it will be easier for them to solve or to simplify using the quotient rule. Yes, we are going to copy the base and then also, of course, subtract. But you look at the exponent. Look at their exponents, which is greater, 8 or 3. Of course, the 8 is greater than 3. So you're going to subtract or put your exponent, or you will do the subtraction in the area where the exponent is bigger compared to the other one. So since 8 is bigger, that's why we do the subtraction of exponents in the numerator, not in the denominator. Okay? That's why we have this x to the power of 5. So what about this one? X cubed over x to the power of 8. This one. How will you do this one? We can still apply. So since 8 is bigger than 3, so we will do the subtraction in the denominator. So just copy the base x and subtract 8 minus 3. So what will happen? There's no more numerator, sir. Of course there is. Since you bring it down, therefore, what will be left here will be 1, not 0, not nothing. Okay? Because you bring down the x cubed down here. That's why we have it x to the power of 8 minus 3. Then you have it 1 over x to the power of 5. So easy, right? So that's how you do it in other way or another techniques. I hope you're learning so far. So that ends our topic in here. So let me remind everybody about our learnings this after our in this video. So the properties of exponents or the laws of exponents we have. Actually, the negative power property will be tackled in the next video. The product of a power, the power of a power, and the quotient power property. So there are three things in here, but I added one, which is the product of a power. So I hope everybody will be able to memorize the laws of exponents, because that is very helpful in the next or upcoming topics in algebra. I know that most of you are very excited and forgetful sometimes, but it's not an issue. It's not an excuse. So I know you can do it. Thank you for listening, everyone. So thank you, subscribers. I hope you are going to invite more people that you know, especially people or your friends who are struggling in mathematics. This will help them a lot. Okay. So every one of you, thank you so much for listening, for staying so long in this video until the end. So I would like to shout out all my students, especially in grade 7, Walling Walling. Hello. And also for my SSP group. Okay, for those who are not mentioned, I would like to mention all of the subscribers who are keep on subscribing me since the beginning or since the start of my video. So I am now, do not forget before we end this, I would like everybody, if you enjoy watching this video, then you can just click subscribe, click share, and then you can just share it to your friends. That's it. If you have some concerns, you can just post it in the comment box. So meaning to say, you can also request, okay, what topic that you want me to discuss. Okay, so that's it. So have a good day, have a great day, have a cute cat. Okay, welcome and see you next video. Hmm.